Hey guys, so let's continue the functions. We're talking about hyperbola. Ne? Okay, easily, hyperbola are those kind of functions that look something like this, right? You have your Cartesian plane right there, then you would have something on the side. Oh no, you'd have something on the side, you will have something on the side, right? These are typical hyperbola. You could have this, you could have this, right? So the green is f of x and the red is g of x, right? This would be like your standard hyperbolic functions. Ne? And I'll leave this diagram here to explain something later on, right? As for the structure of a hyperbolic function, like, for example, right now, we know if you have an equation, and that equation, it's of course, it has a couple of terms, maybe two, right? And the highest exponent or the highest power is one, right? You have a function where the highest power to a variable is one, and we only have one variable. We are talking about linear functions. But if we have one variable, which is x, and the highest power is 2, then we know there's a quadratic equation. But now for a hyperbola, this is basically how you spot a hyperbola. So I I can write it as 1 over x multiplied by a, right, plus q. So x is a denominator. Wherever you see x being a denominator, then you know this is most likely going to be a hyperbola. And so you have your a there over x plus q, right? So I think the easiest we can talk about q. This q, it's gonna tell you something. This is where we introduce this. There's a line that we call an asymptote, right? An asymptote is a line, so we can say this would be your asymptote, right? This will be your asymptote, right? Which it is a line that our functions will approach, but it will never touch nor even cross. I mean, to cross you need to touch. So like our functions will approach this, but it will never touch it. Yeah, like it will approach it, but as for touching it, it doesn't touch that line. Those lines, we call them what? Those are the lines that we call asymptotes. Ne? And this one, q here, it gives us what? Our vertical wait, no, it gives us horizontal horizontal it gives us horizontal asymptote, right? So that's horizontal asymptote. Then furthermore, about q is also what? It is the vertical shift, right? Q is the vertical shift. So, and then after this, bro, we are done talking about q. Let's make it easy, né? To make it easy, q is a vertical shift, meaning that this is our function. Q is the one responsible for making our functions to go up or to go down, right? Going up, going down, that is q, right? And also I want to say this, the same is true also for parabola, because I didn't talk about the shifting there with the parabola, but the same is true also. Q is the one that determines, right, the shift, and the shift, it happens relative to the origin, right? So if you see a +2, it means from the origin, which is 0 0, we shifted 2 units upwards, yeah? And if you have -5, then you know we shifted 5 units from the origin, yeah? This is always true unless your function had already shifted and then we do a further shift. Then your shift will not be from the origin, it would be from the shift that has already happened. Yeah. Cool. Let's keep cooking. And then talking about A, right? A, all I can say is that this gentleman tells us about the shape. Now, so before the shape, I just want to say about the asymptote again. Grade 10, we only have one asymptote, right? Which is the horizontal asymptote, right? But when we get to grade 11 and 12, we're going to talk about vertical asymptote and horizontal asymptote. So we have two asymptotes, right? Cool stuff, cool stuff. This is only like I'm just talking about hyperbola. And I think, yeah, so now I say A, it determines the shape of your parabola, né? And this is gonna be really beautiful. You guys know if I have a function that is like this function, because it's like this, you know it's a decreasing function, right? Implying that it has a negative gradient, né? And if I have a function that is like purple, then I know that function it's a increasing function and therefore it has a positive gradient, né? So now talking about A, if my A is negative, right, this is this is what it's going to look like, right? We're gonna have one that side and one this side, right? And when you draw a straight line, yeah, when you draw a straight line cutting through the two graphs, it will be a negative. You will have a decreasing function, a decreasing straight line, right? And then if A, so I'll say here A is smaller than 0, right? And then if A is greater than 0, you will have a straight line like this, and of course this is A greater than 0, right? So you will have a straight line that is increasing, right, and have a positive gradient. That's the structure. Yeah. So these two lines also, we're going to talk about them. No, it's not them, it's not them. Yeah, but in grade 11 there's these two lines we talk about. They are called axis of symmetry. So we'll see that in grade 11. For grade 10, these lines that I just drew, this one and this one, I'm only drawing them to show you guys the shape of the hyperbola, what it's going to look like, right? So you know, like when you now draw a straight line that cuts through your two hyperbolas, it's actually half a hyperbola, half another half, right? But yeah, so what am I saying? Here's what I'm saying, eh? Those lines are just for illustration. Yeah, well, or they are just there to help you remember to say, oh, so my hyperbola is like this. So if I draw a straight line like this, I'm gonna have a decreasing straight line. That means the A has to be negative. Do you see? Let's get to work. Let's get to work. So you have these, ne? You have these, right? So we'll deal with them one by one. Let me. Cool. So you have that, right? First and first. Um, cool. With this thing that you have, ne, you now see you have a plus 2. What does that mean? It means that um, our vertical asymptote is what? It's positive 2. So let's draw our vertical asymptote. Right, it goes here where y equals to 2. Right, and now as for the structure of our hyperbola, we have a positive a, right? So we're expecting something like this, right? So that when we draw a straight line, it's an increasing straight line, right? So now what I will say is, look, we don't have a y-intercept here because y-intercept x is equals to 0, right? So for grade 10 we don't have it. Grade 11 and 12 we do have it, but grade 10 with the hyperbola we are focusing on, we don't have an y asymptote, and the reason is your y asymptote x is equals to 0. You make this 0, right? When you make this 0, maths error, right? So now what we have instead is x intercept, né? And x-intercept, this is where y equals to 0, you have 2x, right, minus 2 over x, right, and then then x is minus 2 over 2, which is minus 1, right? So that means here you will have a minus 1 and 0, minus 1 and 0, right? So when it comes to plotting these, then you would know it's gonna be, of course, something like this. We go through minus 1 and 0 and we go down like this, right? And then on the other side we're gonna have something like this, right? And then what I would usually say to my students, I would say, look, once you have that, try to put another extra value. So you go to your calculator, say we want to put 2, so you like 2 and then plus 2, that is 3, right? So then you know here, say for example, that is 2 and 3. Do you see? So and then you're fine, you can say this is what, this is f of x, right? And if they ask you now, let me talk about the domain and the range. So remember, asymptote, it cannot be touched. Yeah, the asymptote cannot be touched. And yeah, so when we say it cannot be touched, we are just saying that there is no y value there. Our function is not defined at that particular y value, right? So what does that say? It then says for hyperbola, for our hyperbola, your range, since I'm talking about y values, so your range, which is y values, oh my word, okay, your range your range for hyperbola is going to be what? It's going to be from negative infinity to here to 2, right? And then 2 is not included, so that's why we make this open bracket. If 2 was included, it was going to be 2 and this kind of bracket, right? So it's just going to be 2, that bracket, and then we make it a union of from 2 to positive infinity, right? This is how your range is going to be, because look here, where y equals to 2, your y values, your function is not defined. But as for your as for what? As for domain, right? Domain will just be negative infinity, 0, union, 0, positive infinity. And the reason I'm saying that is because look, any other x value is defined on this function except 0. As soon as we put 0 there, we get math error, right? Yeah. Also, let me try to show you guys for 2. So say I substitute 2 here, I'm like 2, which is y, and I'm trying to find the x value. So I'm gonna have a 0 here because 2 minus 2, right? So I'll have 0 equals to 2 over x, and look, there is no x value that we can use and divide 2 by to get 0. There is none whatsoever, right? And if you try to make x 0, right, say you multiply by how much? Let's say x squared over 2, just to get rid of this x and still have x on the side, right? So you multiply by x squared over 2. This side you're gonna have 0, this side the 2, and the x you're gonna have x. If x is 0, math error. So that's the whole idea with these asymptotes things. Yeah, cool. Let's see what we have to also calculate the x-intercept, axis of asymptote. We have spoken about it. Let me see what's left. I think that's it, right? So with the same ideas now, we can do what? Let's do another function. Beautiful. No. Beautiful. So now I'm gonna take this guy. A1 yeah, so now I think maybe let me not do this one. After this one we'll just jump and do this. So here, bro, the thing is, you have a negative value of a. Our a is negative, so that means it being negative, we are expecting something that is gonna be like this, right? And then when we draw a straight line, we have a straight line that has a decreasing function, decreasing gradient, right? But first thing first, we start with what? We start with our asymptotes, right? Which is 7. So say 1, 2, 3, 4, 5, 6. Okay, 2, 4, 6. Say this is 7, right? 2, 4, 6. This is 7. It's a straight line. It's a straight line which is also dotted. Cool. So, and then here I have y equals to 7, right? So now I know my graph, it has shifted 7 units up high, right? And I know it's gonna be something, this is going to be exactly the structure of my function, right? And this side I'm gonna have something like this as well, right? And I want to say this, so just for vibes. So grade 11 we talk about a over x plus p plus q, right? This is what we talk about in grade 11. So, and then this right here, it becomes what? It becomes the, let me see, vertical asymptote, right? It becomes the vertical asymptote. So, and in grade 10, this is what? It's equals to 0. So that makes 0 to be our vertical asymptote, meaning that this this is where our vertical asymptote is. So that's why our graphs, they will never touch or cross the y-axis, right? Yeah, they will never. And it's just like I said, we don't have y-intercepts here. So, and y-intercepts, that's where x is equals to 0, right? So we don't have that for grade 11, for grade 10. For grade 11 and 12, yes we do, right? So let's stay in our lane. So yeah, this is the structure, and you don't need much. You see, once you put on your asymptotes, you see the value there, you already have the structure. You can just draw it with a black head, like not really thinking much, ne? Because you know that your graph will never touch the y-axis and the asymptotes. It can cross the x-axis, right? And then afterwards, what do? You solve for the intercept, which is what? Which is x-intercept, where y equals to 0. All right, then you have 4x 7. All right, therefore what's happening here? Therefore x is 4 over 7. So here, yeah, let me see, minus 4 over minus 4 over 7. What's happening? Okay, let me try to do this guy step by step. Over 1, we cross multiply, and then I have 4, I have 7x, x equals to 4 over 7. Okay. Oh, I see. This divided by 4 over 7, it's gonna be minus 4 multiplied by 7 over 4, which I have minus 7 plus 7, which is 0, which is here. Exactly. Cool. So this is 4 over 7, 0, right? So and then put on maybe some other extra value, say maybe 4, right? So you put 4, that means we're gonna have minus 4 divided by 4, and then you have plus 7, right? Plus 7, which is 6. So then here you could say you have 4 and 6, right? And then once you have done that, you are done, bro, right? You are done. Domain is always the same. It's gonna be, so domain is gonna be from negative infinity to 0, union 0 to positive infinity, and then the range is gonna be something similar, negative infinity. Now we're going to 7 union 7 positive infinity, right? And yeah, bro, yeah, let's talk about this and try to see what's happening here. So here you have this function, right? They like, what is the formula there for our function? You know, you have y equals to a over x plus q. You see your q is 3, so you like y a over x plus 3. After substituting this, you then substitute the other point that you have. It's 5 a over minus 1 plus 3, right? So you have negative a plus 3, 5. Therefore a equals to 3 minus 5. A gives you what? Gives you minus 2, right? And therefore you have y equals to minus 2x plus 3. And it makes sense why we have minus 2, because when we draw a straight line, it's a decreasing straight line, right, with a negative gradient. Yeah, what about, yeah, and of course for q it's very simple, it's the asymptote. Here we have y equals to a over x plus, then you say 2, you substitute another point, you have minus, oh, here you have 0, then you have a over minus 1 plus 2, and therefore a is going to be 2, and therefore you have y equals to 2 over x plus 2. In fact, we did this function, right? So now you realize that everything makes sense, because we have this straight line, which is a positive or increasing, you have a straight line, and our q is 2, right? Let me call this the end of this video. We'll see you in the next one.